For a long time, astronomers thought they understood how planets form. Dust turns into rocks. Rocks turn into planets. But then, we started finding planets that break every rule. Planets that are hotter than stars should allow. Planets drifting through space without a sun. Planets with densities that make no physical sense. These worlds shouldn't exist, and yet they do. This is the story of 5 real exoplanets that forced us to rewrite planetary science. Beginning on our list, WASP 12b, astronomers call it a hot Jupiter planet, a gas giant larger than Jupiter, orbiting absurdly close to its star. So close, in fact, that it completes an orbit in just 1.1 days. So your birthday would arrive every day on this planet. At this distance, the planet's atmosphere reaches temperatures above 2,500 Kelvin, hot enough to vaporize metals like iron and magnesium. But here's the problem. Gas giants cannot form this close to a star. There simply isn't enough material in the protoplanetary disk. So how is it there? The only explanation is planetary migration. WASP 12b must have formed far away, then spiraled inward over millions of years. And now, it's paying the price. The star's gravity is stretching the planet so intensely that its atmosphere is literally being ripped off, forming a glowing tail like a comet. We're watching a planet die in real time. HD 189733b looks like a normal blue world until you understand what's happening there. This planet has winds blowing at over 8,700 kilometers per hour, nearly 7 times the speed of sound. And those winds carry clouds made of silicate particles, in other words, molten glass. As the temperature drops on the night side of the planet, this glass condenses and falls as rain, sideways, slicing through the atmosphere. Rain that moves horizontally at hypersonic speed. No planet was expected to sustain weather this extreme. Atmospheric circulation models simply didn't predict it. HD 189733b forced scientists to completely rethink how atmospheres behave under extreme radiation. 55 Cancri E is a super-Earth about twice Earth's size, but don't let its name fool you. It orbits its star so closely that its surface temperature exceeds 2,000 degrees Celsius. This isn't a rocky planet, it's a global magma ocean. Entire continents of molten rock flow across its surface, constantly reshaped by tidal forces. But here's where it gets strange. Based on its mass and radius, some models suggest 55 Cancri E may be unusually rich in carbon, potentially forming layers of diamond beneath its surface. A planet made partly of diamond was never something planet formation models predicted. It challenges what rocky planet even means. This planet orbits a pulsar. Oh wait, you heard it right. A pulsar is a neutron star, the ultra-dense corpse left behind after a massive star explodes as a supernova. During that explosion, the energy released is so extreme that it should obliterate anything nearby. And yet, PSR B1257+12b exists. Not only that, it was one of the first exoplanets ever discovered. This planet either survived a supernova, which seems impossible, or formed after the explosion from the debris of a dead star. Either way, it proved that planets can form in environments we once believed were completely sterile. Planet formation is far more resilient than we imagined. If you are enjoying the video, subscribe and turn on the notifications so you don't miss any of our future videos. Now for the most unsettling case, rogue planets. These planets do not orbit any star. They drift alone through interstellar space, ejected from their original systems by gravitational chaos. We estimate there may be billions of them in the Milky Way, possibly more rogue planets than stars. And here's the terrifying part. Some rogue planets may still have subsurface oceans, internal heat and chemical energy sources, meaning life could exist on a planet floating through eternal darkness. Planets were supposed to need stars, but the universe disagreed. Every one of these worlds broke a rule we thought was fundamental. They showed us that planetary systems are chaotic, violent, creative. Our solar system is calm, but it is not normal. And if planets can exist in conditions this extreme, then life might be far more adaptable and far more common than we ever imagined. The universe isn't just stranger than we expected, it's stranger than we were ready for.